Go ahead. This is 4.3. We're solving equations involving fractions this time.
Rock gardens are a fascinating tradition in the Japanese culture. Their beauty is a result of careful combination of natural landscape and artistic design. The peaceful atmosphere of a Japanese rock garden can provide moments of quiet reflection, contemplation, and appreciation of the simple beauties in life. How can mathematics be used in the design of a rock garden?
All right, so what techniques can you use to solve the equations involving fractions? So it says, Kumiko is designing a rock garden in the shape of a trapezoid. She decides that the garden should have a front width of 8 and a depth of 5 meters. The area must be 50 meters squared to fit her design. How wide should Kumiko's garden be at the back? The formula of the area for trapezoid is area is equal to A plus B times H divided by 2. Substitute the known values into this formula. So here we're given all the values here of A, B, capital A, and H. So we can substitute all those values into this formula and calculate the variable that we need. Okay? Find the value of the unknown, in this case B. So there's our value of B. So the way we do that, we substitute in our values. So 50 for A is equal to 8 for A plus B times H is 5, all divided by 2. Yeah, sorry. Was I off screen there the whole time? Yeah. Alright, yeah, just don't be shy. Let me know. If I'm off screen, just yell it out and I can pull it up. Okay, so here we have an equation now. Here's our unknown variable. It's pretty guarded, right? It's stuck in a bracket. It's part of a fraction. So we got to do some work here to get that variable b out, and preferably on the left-hand side. Any ideas what we can do? What might be the first step? Yeah.
Well, we can take away divided by 2 and then go to 25 equals 8 plus b times 5.
No. You're close. Very close. What do you do wrong, Alvin?
Multiply 50 by 2.
Right. So yeah, to get rid of the 2 atom, we actually have to multiply by 2. So they go, and the 50 becomes 100, not 25. Okay? But everything else was right. Yeah. So that's the idea with fractions. To get rid of them, we want to multiply by the denominator so they cancel out. Okay? The other term will just get bigger, but the important part is that we'll no longer have a fraction. So what happens then is we end up with 100 is equal to 8 plus b times 5. Any questions about that? Why that fraction went away, Christian?
I understand why that fraction went away, but if we're multiplying everything in the fraction by 2, how come the 5 didn't become like a 10?
Because the 5 is part of this term. This is one term. Remember I said terms are separated by either only additions or subtractions? So this 5 is actually being divided by 2. So this is actually 2.5, right? If you think about it. So now I'm multiplying it by 2, so the 2's cancel, so it is actually 5. You see what I mean?
Yeah.
It's hard to explain, but it is part of that fraction. So that 2 crosses out with what's on bottom, and it's still part of the 5. Okay? Similarly, the stuff in the brackets, 8 and b, they don't get multiplied by 2 either, because this 2 on the denominator has taken that 2 right out. Okay, that's what crosses it out. Right? It's like half of this whole term, half of it times 2, well, it's going to be, again, 1. It's going to be that whole term, right, on top. You guys get that? Any other questions about that again? All right. So now what do I do? Henry.
Decide by 5 to get rid of the 5 on the outside.
Very good. So some of you might have said was multiply the 5 out, which you could do. Okay, you could expand and then simplify. But Henry said, well, let's get rid of this 5 right away, so let's just divide it out by 5. Okay? And this way is a bit quicker. Okay? But it's important that you guys start to recognize things like that, because it's going to make your life a lot easier. All right? We could have expanded this, so we would have had 100 was equal to 40 plus 5b. We would have ended up with the same answer. So leaving b on the right just because it's positive, so it makes it easy. 60, right? So b is equal to 12, okay? Same thing over here. B is going to be 20 minus 8 is 12. Okay, do you see there's just one step saved? Or it's kind of actually the same, but in either event, I didn't have to expand here. So yeah, I saved one step. Any questions there? Yeah.
Could you explain how you got to that answer again?
Sure. So from this point, 100 equals 8 plus b, 5?
Yeah.
All right, so we know we want to find b on its own. So to get b on its own, we need to do opposite operations. So right now it's getting multiplied by 5, so we're going to divide by 5 so we can cancel the 5's out. 5 divided by 5 is 1. So whatever we do to the right-hand side, we have to do the left-hand side. So because I divided by 5, I'm going to divide this side by 5. So 100 divided by 5 is 20. So do you understand up till here?
Yeah.
Okay, so now we have 20 equals 8 plus b. We move the 8 over. It becomes negative. 20 minus 8 is 12. Okay? Any other questions? All right. So let's look at some examples now. So these all have fractions in them. Luca in the back, what might we want to do to get rid of this fraction?
You have to multiply
Yeah, times it by
6, 7?
6 or 7? No.
No, I'm a bit confused.
Okay, tell me why.
I don't know. I don't understand.
Okay, so pay attention, okay, to this one, all right? We're going to try and go back and explain it again slowly. So we want to get rid of this 3, right, Luca? We don't understand, okay? We don't want to deal with fractions. So in order to get rid of a fraction, remember, it's divided by 3. We have to do the opposite operation. So we need to actually multiply this, everything by 3. Okay, why? Because 3 times a third, or 1 over 3, is equal to 1, right? So if I multiply this by 3, this 3 and this 3 cancel. But whatever I do to the right-hand side, I have to do to the left-hand side to keep the equality. So I have to multiply 6 by 3. Okay? So the 6 down here becomes times 3 becomes 18. And see this 3 times 1/3, that becomes 1. So these go away. And you're left with 8 plus x. Do you see that? Yeah, Tyler.
I have a question. So you know how it says 1/3 over there, right? I was thinking like you do the opposite, so you multiply, and since we know that when you're dividing fractions, you just flip the denominator and numerator. Wouldn't you get the same answer as well?
If you did what?
If you divided 1/3 and then you divided it by 3 over 1, and that's just multiplication, you get the same answer.
No, if you divide 1/3 by 3 over 1, that's going to be 1/3 times 1 over 3, which is 1 over 9.
Well, I meant like, so 1/3, right? And then you divide it by like 1 over 3, you still get the same answer. It becomes 1 over 3 multiplied by 3 over 1.
Why would you think of it that way, though? Why not just multiply it by 3?
I don't know.
I don't know either. It's an extra step.
Oh, this is like the first thing that happens.
Okay. I guess, if you want to think of it that way, it's fine, but you're just multiplying it by the denominator to cancel it out, right? Yeah.
Can you move the 1 over 3 over the equal sign so then it becomes 1 over 6 divided by 1 over 3? Then it's 6 over 1 divided by 1 over 3. And then that equals 18 over 1.
Yeah, that's what I was going to say.
You could, yeah. It's just a lot more complicated, yeah. You could, so you divide both sides by 1 over 3. So this becomes 1, and this becomes 6 times 3 over 1, which is 18, yeah. But I don't understand why we just don't like the concept of 1 over 3 times 3 is 1. Right? Instead of dividing and flipping fractions. You have 1/3. You have 1/3, 1/3, 1/3, right? 3 thirds, 1, right? So once we do that, and either way, yeah, then we get 18 equals 8 plus x. We move the 8 over, 10 is equal to x. Any questions with that one? Robert, B.
So you're going to multiply them by 4
Good,
for the fraction.
good. So what's that give me?
3y minus 5 equals 28.
Okay, careful now. You said 3y minus 5. That would have been wrong. It's 3 times y minus 5.
Oh.
Right?
Yeah.
Okay. So what's next?
Then you use the, I forget what it's called, but then you do 3 times y,
Yeah?
and you get 3y, and
Mhm.
then 3 times negative 5, and you get 15.
Negative 15.
You get negative 15.
Yep.
And then you you leave the 3y on the left side.
Good.
You bring over negative 15 and becomes positive 15.
Excellent. Yep.
And then you add it together and you get 3y equals 43.
Mm-hmm.
And then you leave the variable on that side,
Mhm.
you leave the 3 over, and it becomes division.
Good.
The answer is 43 over 3.
Excellent. Very good. Perfect. Adam.
When you multiplied 7 by 4, don't you have to multiply 3 by 4 as well?
No, because the 4 on the bottom takes it out.
Oh,
Because this is all one term. Right? So it's 4 divided by 4. So these guys go. Right? Let's write that out in it's right here. See? See this? 4 times 3 divided by y minus 5. These 4's cancel. Okay? All right, we're going to get a little trickier now. Now we have 2 different denominators.
Ah, you gotta make one comment.
Kyle in the back. Any ideas? Without looking at the solutions, tell me what you think. So previously we'd been multiplying by the denominator, right? So if we did that in this case, if we multiplied this by 3, we'd be good. But then if we multiplied this by 3, we're not going to be good, right? We're still going to have 3/5. Right, you got to find a common denominator, right? And they call it the lowest common denominator. Why the lowest? Yeah.
Because if it's not the lowest common denominator, when you go to multiply, you have to simplify it out.
Right, it'll just be bigger. Right, exactly. Perfect. So we want the lowest common denominator. Good. So between 3 and 5, Kyle, what would that be?
15.
Good, 15. Excellent. So we're going to multiply both sides by 15. Okay, so that's what we see happening right here. 15 times k plus 2 over 3, and 15 times k minus 4 over 5. So the 15 now cancels with the 3 and becomes 5 on top. Right, because 15 divided by 3 is 5. So that's why we get a 5 here. Okay? Next, the 15 cancels with the 5. 15 divided by 5 is 3. So that's why we get a 3 here. And the fractions are gone. Okay, any questions to there? Joseph.
So every time you do this, the lowest common denominator you find, you have to divide that by the denominator that you had before.
Not divide, multiply.
No, but like when you got CODs, you got 5k, 5, and then in brackets k plus 2.
Yeah,
Before that, you did 15 divided by 3.
right.
You have to do that like every time.
Yes, so if I'm multiplying this by 15, that's the 15 and the 3 have to divide to give me 5.
Okay.
Okay? Any other questions? Adam.
So can't you just switch the denominator?
Switch the denominators.
Just switch 3 and 5 and make multiplication instead of division on the bottom.
So put the 3 up here and the 5 up here?
Yeah.
Yes. That's called cross multiply. I don't like teaching that necessarily right away because it gets really confusing. Now people are switching sides without changing signs. It gets confusing. I'd rather teach it like this, at least initially. Okay? But yeah, you're skipping a step there. Okay. Next, now it's just an expand and simplify, gather like terms, solve for the variable question, right? So we do 5 times k plus 2, we get 5k plus 10. Other side, we get 3k minus 12. We put the variables on the left. 5k minus 3k is 2k. Negative 12 minus 10 is negative 22. K is equal to negative 11. Any questions there? All right. B. Here's our question. Matthew. Good. Yep.
B.
Yep. Right here on the screen.
So what you want to do is you want to find the lowest common denominator for each and 12.
Mm-hmm.
And then you would put 12 beside 1 over 3 equals 4.
Yep.
And then you would divide 12 by 3, which equals 4.
Good.
And then you would divide 12 by 4, which equals 3.
Yep. Good.
And then it would be, then you would expand, so it would be 4 times 2x.
Mm-hmm.
And then you would get 8x.
The only trick here is that there's a 3 right here, right? So you got to make sure that that 3, even though the 12 cancels with the 4, it's still going to become 3 times 3. Does everyone see that? Everyone see that, right? So 12 times 3 over 4. The 12 divides into the 4, nice. So we're left with 3. But we still have a 3 on the numerator that we need to multiply by that 3. That's why this becomes a 9 here. Okay? The reason it didn't happen on the other side is because we just had a 1. You guys see that? All right, so then we get this. We expand 8x minus 20, 9x minus 18. Put the variables on the left. So 8x minus 9x would be negative x. See, they went to the right because they wanted to keep x positive, but it's okay. We could have gone to the left. Negative x is equal to negative 18 minus 20 is negative 38. X is equal to 38. Okay, dividing both sides by negative 1. I made a mistake. Hold on, sorry. Negative 18, sorry, my bad. Negative 18 plus 20 is positive 2. So x is equal to negative 2. Sorry about that. Any questions? All right, that's the end of the lesson. It's very quick. Key concepts: you can simplify equations involving one fraction by multiplying both sides by the denominator of the fraction. When eliminating more than one fraction, find the lowest common denominator and multiply all terms on both sides of the equation by this value. Very simple. All right, very quick, short lesson. Any final questions for 4.3? No?